In this exercise, we have a scenario. Imagine this is a neighborhood. This graph right here represents a neighborhood. And now we have a delivery mail person that's going to be delivering mail from this right here. So they have the little car. I don't know how to draw a car, but that's good. They have the little car right there, parking B. Now this delivery person wants to go through the entire neighborhood without having to go back to another edge. So let's say he does not want to go from B to E and then go back in the same line. Does not want to repeat, right? You want it to be a path. A path is when you don't go through the same edge again over, right? So let's rewrite this part right here. So delivery is park in B. He wants to walk the entire neighborhood without having to go over a edge again, a path, edge, a path, okay? So for question part A, let's see what it says. Use Euler theorem to explain why is it possible for the mail carrier to park in B, deliver the mail through each house without retracting her route, then to return to B. So you want to look for a circuit to see if there's a circuit here where I can travel the entire neighborhood without having to repeat the path and end in B. So let's see. For part A, to make sure, I'm going to look for how many vertices do I have in B, C, D, E, F, G, H, and I. Now, do remember, if we have all even vertices, we have a Euler circuit. So in A, I have 1 and 2. B, I have 1, 2, 3, 4. C, I have 1 and 2. D, I have 1, 2, 3, 4. E, I have 1, 2, 3, 4, 5. Let's count again. 1, 2, 3, 4, 5, 6, 7, and 8. I have 1 and 2. 1 and 2. 1, 2, 3, 4, and 2. Now, if you see, all your vertices are even. Therefore, we do have an Euler circuit. Where you start, you want to end. So for part B, it says to use trial and error of Fleury's algorithm to find a Euler circuit that starts and ends at vertex B on the graph. So I want to start at B and end in B. So I need to find that circuit. So if I start, let's see, let's use a different marker. I go from B to C. Maybe we should do B to A. From A, I go to D. Then I go to G. Then I go to H. Then I go to E. Oops, E. And then I go to back to A. Let's see, H. Yeah, H. Then I go to I. F. Back to E. Back to F. I go to C. I go to F. Go down here. I go this way. Then back to E. And then I'm back in B. So let's write it down. That way it's able to see. And from B to A to D to G to H to E to D. Gonna keep writing them here. E, and we're and in B. So we want to make sure that I start in B and end in B, because that's what happens when you have a Euler circuit. You want to make sure you don't go through the same edge twice. You can pass the same vertex, but not the edge. So you cannot go, oh, I went from D and then, oh, came back. No, you do not do that. Cannot do that. Okay? So to check if you have an Euler circuit, you count the vertices and you see how many edges go into each vertex. If they are all even, then yes, you do have at least one Euler circuit. And then you got to remember, a circuit, you must end where you started. So those are your answers for this example.